Okay, continuing on with this problem, we get the variables all to the left-hand side, so we subtract 9p from each side. We get a negative 2p plus 13 equals negative 5. Now we want to get that creepy dude, that p, all by himself again. So we follow the order, going up the order of operations. What's being added or subtracted to him would be a positive 13. To get rid of a positive 13, we go negative 13. That'll wipe out. We have a negative 2p equals a negative 18p, or 18. Then we'd divide by negative 2 on each side, and we would get p equals 9. Continue on with this. Number 11 probably causes a little bit of trouble here for us. You shift it over just a little bit to make sure it's in your view. First thing you do with parentheses is to distribute, to clear those out before you start trying to deal with your creepy dudes or your x's. So we go a negative 8x, negative 4 times 5 would be a negative 20. 2 times negative x would be a negative 2x. 2 times negative 9 would be a negative 18. And then negative 4x. You notice how we have like terms here and here? Those are on the same side of the teeter-totter, so we just go ahead and move those together. Negative 2x and negative 4x would be a negative 6x minus 18 equals negative 8x minus 20. Now we're still trying to deal with our creepy dudes. You don't want to do anything till you have them all together. So to get rid of this negative 6x on the right-hand side, we would add 6x to each side. We end up with a negative 2x minus 20 equals negative 18. This wipes out. Now we add 20 to each side, getting that creepy dude alone. That wipes out. We get a negative 2x equals 2. Divide by negative 2 on each side, and we end up with x equals a negative 1. Next problem. Draw a line down. Subtract 2x from each side. This ends up being a negative 4x plus 9 equals negative 7. That wipes out. Now we have our creepy dude. We're going to get him alone. You go up the PIMDAs. What's being added or subtracted over here by the creepy dude? It would be a positive 9. To get rid of that, it's minus 9. That wipes out. We have negative 4x equals negative 16. To get rid of that negative 4, it's being multiplied, so we would divide. And we end up with x equals positive 4. When I deal with fractions, a lot of times when I see fractions in a problem, I will simply just multiply by a common denominator to get rid of every fraction in the problem. 4 and 5 both go into 20. So I multiply everything in here by 20. One-fourth of 20, 4 goes into 20, 5 times. And 1/5 of 20 would be 4, because 5 goes into 24 times, but we have 2/5, so that's 8. And then 20 times 39, $780. We end up getting 13x equals 780. We've still got a creepy dude trying to get rid of him. So we divide by 13 on each side. 13 will go into 780. 6, I believe, because 6 times 3 is 18. 6 times 1 is 6, plus 1 is 7. 78 there. Don't forget to bring a 0 up for the 780. So x equals 60. Down here we distribute again. Get rid of the parentheses. So we have 3y plus 6 equals 5y plus 20. We got creepy dudes on both sides of the teeter-totter. Let's get them over to the left-hand side. Minus 5y, minus 5y. We end up with a negative 2y plus 6 equals 20. Now we try to get this creepy dude by himself. We subtract 6 from each side. That wipes out. We get a negative 2y equals 14. Move it up here. Negative 2y equals 14. Divide each side by negative 2. And we see that y equals negative 7. It is expected that you'll be able to do these problems. They're a review problem. We'll be practicing them in class tomorrow. So now on marking your inequalities, an inequality that is less than, we simply make it an open circle, and it goes the same direction on this arrow as that inequality, as long as the variable's on the left-hand side. So that would be on a number line at 2. This one would be a solid circle because of that equality underneath. Go in this direction, so it's at negative 3. This is a complex inequality. It's two inequalities hooked together. It's like a great big hug. You're going to get everything inside of it. So, knowing that, go straight to your graph. This would be a solid circle. This would be an open circle. Connect it like a hug. Bring down your answer, bring down your answer. So anytime you see that, go right to the graph. When you see an OR graph, that's your other option of a complex inequality. OR means that they don't come together, they go away from. OR means you can't have both. So this would be an open circle and it goes out that way. This would be a closed circle and it goes out that way. The 1 goes under this one, the 3 under that one, and we're all set. Going down to inequalities to solve them. 4 plus 9, we don't have an x in there, let's put an x in there. 4x plus 9 is less than 25. Draw a line, circle your creepy dude. To get him alone, we first have to subtract 9. Subtract 9. That'll wipe out. We get 4x is less than 16. Now, 4 times x, we need to get rid of that 4 times, so the inverse would be divide by 4. So x is less than 4. Your graph would be an open circle going that way at 4. On this one, we have a creepy dude on each side of the equation. Draw your line, get them all gathered over to the left-hand side. That'll cancel, so we have a 0 over there. Less than or equal to negative x minus 7. To get that creepy dude by himself, we would add 7. So we have negative x is less than or equal to 7. Now to get rid of that negative, we think of it as a negative 1 being multiplied there, so we divide by negative 1. X is, when you divide or multiply by a negative number in an inequality, You need to flip the sign, so it was going that way, it now needs to go this way. And 1 goes into 7 times, so it's -7. On the graph, you would write -7, closed circle, and it's going that direction. It needs to match your inequality sign. Next one, we have a creepy dude on each side. So we subtract x, this will wipe out. We get 3 minus 2x's is greater than -9. Now we need to get the x by himself, but be careful on this kind. Sometimes you'll be tricked into thinking that that's a -2. It's still a times 2 because it's sitting right next to the variable. Instead, we need to get rid of this number farther away, which is being added. 3 minus 3 will wipe out. -9 minus 3 is -12. -2x. Now we divide by -2. Divide by -2. X is greater than 6. Now, what's the mistake that I made there? Take a close look at that. Hopefully, you have said that I divided each side by a negative number. That should be flipped, and that is correct. That is an incorrect answer. X is less than 6. So it should be graphed with an open circle at the 6 going that way. Okay. Here we have the complex inequalities. You look at it and you see a hug, so come down and put the open circle, connect it. Now we go up and we answer. Put in your teeter-totters. This is a complicated teeter-totter, only one creepy dude though, and we look right at him. How do we get him alone? We subtract by 7, and we need to subtract by 7 in every part of the teeter-totter to keep it all balanced. -1 minus 7 would be -8. -7 and +7 wipes out, the whole reason we chose 7. 19 minus 7 is 12. Bring down your inequalities. And what's left on the inside? Still trying to get him alone? So now we divide by 2 everywhere. So we have -4 is less than x, which is less than 6. So bring those numbers down to your graph, -4 and 6. The next section, it's another hug, an open circle, and this time a closed circle due to the line being underneath it. So there we go. We draw our lines. To get x alone, all we have to do is add 5 to each side. This will wipe out. We get 11. Bring down our less than. Bring in our x. Less than or equal to -8x, or -8 and a +5 is -3. So we bring those numbers down to the graph, -3 and 11. Okay, when we get to the next inequality, we solve them as 2 separate problems because their graphs are completely separate. Open circle going that way, closed circle going this way. Get the x alone, we subtract 4 from each side. X is less than or equal to 5. We add 3 to each side. X is greater than 10. So you're done. On this one, draw the line down. It's going to be an OR graph, so we can go ahead and put the open circle, draw in that way, close circle, because you've got the equals to sign drawn that way. Okay, to get the creepy dude alone here, we need to add 1 to each side. That'll wipe out. We get 3x is less than 0. Now we divide by 3. 0 divided by 3 is 0, so our number's 0 there. Here we subtract 5 from each side. That wipes out. We get 2x is greater than or equal to -4. And divide by 2 on each side. We have x is greater than or equal to -2. Now if you think about this, that problem's got an error in it because it wouldn't be greater than -2 over on this side and less than 0 on that side. If that were the case and it was greater than -2, which that's on this side of 0, then they would actually be connected and it couldn't be an OR. So that is a problem with a typo in it. But you always want to be aware, does the math make sense? And is it coming out where it would make sense? That is the end of the notes for the first day. If you missed the first day class, that's what we did. So you need to come in during lunch, before school or after school, and work on this assignment with me. Make sure that you have it down. You will not be given credit without coming into work for a half an hour. Okay. Thank you very much.